really difficult, especially because oftentimes you want it to be really efficient. So a lot of times in these things, the reflection uses aren't as rigorous as they
in the end, you're going to produce a language term, which is type-checked in the same way.
Talks slash
performance
blog
pieces.
Posts on his very minimalist reflective calculus that literally the descriptions of everything are described as reflections in the calculus itself?
I don't think so.
That sort of serves as a counterexample to your point.
Well, if they embed it in Agda, then you can actually prove the term is correct. That's how it's supposed to be. What you're supposed to do in the other cases is take your ML program and write Hull proof, say, that shows that this ML program actually correctly implements the reflection algorithm.
Yeah.
That would probably take several years to do, so they just don't do it. They just kind of say, they might do some hand proofs, and we're like, it's close. And then
In practice, if a thing doesn't work, you haven't lost anything but time, right? If you work really hard to make a really good prover that happens to be incomplete,
it's not a matter of it being incomplete. The
it's
ML thing, basically,
who cares?
This reflection, you're saying this decider, this.
You can't show who cares in the middle of an Agda talk.
No, but I really can. I mean, who cares if as long as it's right most of the time and performs well. If it turns out that it generates something erroneous, that's a problem. But it doesn't invalidate any of the things that proved correctly.
All I'm saying is not
Yeah,
that's
it
actually
invalidates the
important.
things that prove incorrectly.
What's that?
It can prove things that aren't true is the problem.
No, it can't.
Well, any type system is effectively providing you with some little theorems about your code as it goes, right?
Right.
It's working in some logic. That logic may be flawed, but it's providing you confirmatory evidence to your biases, right? In many ways, right?
No, that's not what I mean. That's not what I mean. People may not care, and I'm happy to shut up, but that's not what I mean at all.
So if you have this this tactic that generates proofs for Pressburger,
No, I'm not talking about tactics.
Okay.
Tactics are fine.
Sure.
Tactics are
I think
completely
that's the confusion.
Is it whether the reflection
It's the
is sound?
reflection algorithms. Reflections sound too. You just have to actually prove the
implementation of
precedence. Yes. What do I want to say? The hypothesis is that the decider is correct,
Okay.
which is not normally proven because.
And that's where I'm going to refer you to the Connor's paper all the time.
Yeah. Well, Agda's thing with embedding, I was also right. It's just, I'm saying a lot of other systems don't actually do this fully. I mean, they have reflection, they just don't actually prove it correct.
Fair enough.
So what's the key difference then is that you don't type check the output of the reflection engine the way you type check the output of a tactic?
Or no, it's that the process of reflecting is usually implemented outside of the language.
Basically,
why
you
do you
run
care? You have a completely opaque black box that spits out an Agda term. You can type check that term. You don't need to know.
But if you want to prove something about the guy who spat out the term,
Sure.
then if it's in a different language, then you need to prove that the translation between the two languages is sound, and that's what people want.
But you can just you don't need that for the proofs it outputs.
No, I mean the proofs it outputs are generally fine.
They're proving something about some
It's the
term,
proof
whether that
about
term
the
that you
proof.
actually care about is another matter.
But you'll find out very quickly
Yeah.
if you actually try to use it.
Well, but nobody ever runs an Agda program, so it doesn't matter.
Do they run
No, they just compile it and then it's finished.
Don't even bother compiling; just type check. That's fine.
Yeah.
I'm sorry, that's what I mean by compile.
Calculation
Everything
is-
becomes
is
as
the-
normal as the entire program is.
Calculation is
Four.
the keystroke I never remember. That's
So when you use reflection, is that anything like say template Haskell where you're like splicing in terms that are generated at compile time?
no, it actually.
How does it look syntactically? I guess.
I can't remember what it actually looks like syntactically, but it's basically going to give you you have an ADT for your terms, and it gives you the current goal as in a form of this ADT, and this ADT represents the goal type, and you can massage it until you produce a valid proof of that representation of the goal type.
Okay.
And so the translation between those still would need to be proven.
Yes.
And just to add to the reflection, one example of something that you might use reflection for in other systems is you might use a model checker to check something. And a model checker usually doesn't output anything similar to the proofs of your language. So in those situations, usually just it's a yes or no.
This is correct.
Yeah.
Yes.
It might
Why?
be like a
'Cause
model
I said
thing that you could then verify, like counterexamples, but
Yeah.
you still have to write something.
Yeah. So I'm almost done. It would be nice to have better compilers because some people actually do like to run their code. The current Agda compiler to Haskell is not very good. What it does is actually it takes pretty much the Agda code, because they're so similar, it takes all the Agda code, spits it out in Haskell, actual Haskell syntax, and wraps an unsafe course around every single expression.
Awesome.
So it's basically
That
using
rules.
Haskell as an untyped core language.
There are better untyped core languages than Haskell.
It was convenient because all of Agda is written in Haskell, and I guess they happen to have that lying around.
You already checked it, right?
Yeah, you've already checked it.
Oh, no, that's not the, I just,
Yeah.
there are better untyped target languages than
Oh yeah.
Haskell.
So someone, Edwin Brady, recently wrote an Epic. Epic is sort of core language for these. He uses it for. I can't remember the name of his language, but it's
Igor?
no, it's the other one.
Ivor.
Ivor is the one of the underlying things. It's I can't remember.
I can't remember the other. I can't remember the next layer up.
Yeah. So anyway, he uses it for that, and he wrote an Agda backend using Epic, which is his low-level compiler. Epigram will probably be using that too, which is another sort of exciting language in this space. As I mentioned earlier, it uses a hell of a lot of memory. It'd be nice if Agda improved that.
Get more memory.
Yeah, that's another option. And so, yeah, the dependent types are fun, expressive, and I hope everyone wants to use them now. They're not as simple as just being able to, write arbitrary type level functions and things, because you generally need to prove things about them to be able to use fancier types. It's still not what I call mature. I mean, as I said, people do prove false in it, and for example, the treatment of co-induction right now is a bit up in the air. People are not able to prove things that they would expect to be able to prove, and strange things like that.
You lose some type information when you pattern match.
Yeah, well, I mean, it's part of the issue is sort of well, I mean, yeah, there's you can't pattern match on this sharp guy, and there's a few issues with that, and things that are very obviously equal not being equal because of how it treats co-induction. But that's it's still very usable. You can write lots of programs. There's a fairly extensive category theory library out there, and there are a few other smaller ones. There's Eric Mertens and I worked on a bit vector representing machine words and doing arithmetic and proofs about all that stuff. There's several things because most people don't actually want to use piano naturals for their numbers. It's an active research field. There's a lot of good stuff going on right now. One of the main things is in epigram land is observational type theory, which gives you a much more interesting equality than the one I was using back there. Allows you to prove that functions are equal, for example, and things like infinite data types are equal, and you can have quotients and things, which are things that people would like to be able to use in these languages. There's also other developments along the same, from the same people about generic programming in these languages. I mentioned you can have, for example, one of the reasons I think Agda supports the overlapping constructors that I mentioned near the beginning is because you often define a whole bunch of isomorphic data types with fancier types, depending on what you're trying to prove at the time. A heterogeneous list runtime would probably be very similar to a homogeneous list, or a list with its size represented in its type would be the same as a list without its size represented in its type at runtime. And that kind of stuff, all your algorithms on them are going to be exactly the same. Concatenating two lists, regardless of the additional type information they carry around, is still going to be the same recursive algorithm. And this sort of gives you a whole bunch of opportunities for generic programming, which you don't normally get in most languages. And so there's a whole bunch of work or some work being done in epigram land on representing the structure of types within the language itself. And so you can reason about structure of types and write generic functions about them. And that's sort of exciting because a lot of people don't like to repeat code and don't learn them. And so maybe one day we'll get certified software, but probably not. Thanks.
All right. All right, let's...
Has there yet been a document that relates something like the intended type theory of Agda to
No.
some Haskell file somewhere?
Just some Haskell file. No.
It would be nice
No,
both to
it's
know
not-
what logic is in Thierry's head
Yeah, no.
and how it's realized in some random file somewhere.
I don't believe there's any kind of sort of attempt to make Agda's. You're talking about some of this, sort of going towards the drawing criterion kind of thing about having
It's
sort
not
of
just-
a
not-
checkable core that you can actually.
Hey, I'd like to know what its logic
Yeah.
is. Let's not even get to the point where,
Yeah.
where the software
Yeah.
could be looked at for informal
Yeah,
you know,
I don't think there's.
I'd like to
such
know
a
its
thing.
logic. I know it's supposed to be
There's
MLW+.
a wiki up there,
but
but I don't think it has very much about that kind of stuff.
wikis are not how I want to specify logics.
Yeah.
Like this, doesn't that make anyone nervous?
Yeah. I mean, it is. You aren't 100% sure this guy's.
Well,
it's correct.
I mean, I just see this Bugzilla thing where you're like, the following program's broken, works for me, I proved it works. Because I changed the wiki where false didn't have a proof.
Yeah.
All right.
Yeah. Well, as,
Creepy.
any other questions?
What do you normally do with Agda?
Tinker. As I was talking about the games, I basically pick mathematical statements and try to prove them. They're usually pretty boring because I'm not capable of proving anything interesting. But I don't know. One of the things I was doing when I was just getting started was to say work with even and odd parity of naturals and say, well, two even numbers added together make an even number, and even and odd make an odd number, and things like that. Even very simple statements like that, you can work with them. Or you can do sort of, when I was first introduced to induction in high school, there was the proof that, if you add consecutive odd numbers, you get squares. Proof that in Agda, it's not trivial, even though it's, your most trivial induction proof. And so things like that are sort of just little games for stuff to do. It's not productive, it's not stuff that's going to go down in history. It's fun, and sort of a fundamental exercise.
It's good because I can play him and Russell O'Connor off against each other when
When I need a proof of something, like
Yeah.
about one of my comonads or whatever.
Prove something that isn't a comonad to be a comonad.
Yeah.
That's what he had me do.
Everything is a comonad. It's
it was a
one of the
comonad. We just had the
axioms.
wrong bind.
Yeah.
Or the
Well,
wrong extent.
if you consider the comonad to be the operations plus the underlying structure, then
Yeah.
it's not a comonad. But,
So that was fun. So between him and Russell, I was able to get a proof.
Yeah.
The top one came in first, huh?
yeah. It's,
We still using the old category theory library in COP? Like the one that's like in some tarball somewhere?
Oh, mine or the?
No, the whatever logic you're using or whatever.
Oh, no, that
theory
was
you're
actually,
using
that was
for-
defined in its own little file, just enough to define what a monad is or a comonad and to define the laws for it.
oh yeah. He just defined the laws on the fly. That's what I did too.
All right.
Oh, just as an algebraic thing without
Yeah.
the underlying categories involved?
Yeah, didn't care, just about the algebraic laws.
No, that's fine. That's a lot easier than